Hey physics, I wanted to talk you guys through what we did in activities 1, 2, and 3 so that you can know, this is like if you were not in class or if you just want to go back and check on your answers and make sure that everything's cool, then you can do that with this. Okay, so here's activity 1, the thought experiment. So we're thinking about these two competing theories that were in place for thousands of years really, that are the idea of a continuous model of matter versus a particle model of matter. So we can get into that by thinking about this piece of paper, right? And if we cut this piece of paper smaller and smaller and smaller into tinier and tinier pieces, does it always stay paper, or does it break up into pieces that make up paper, like the building blocks of paper? So, so this one is for you to think about. What do you think? Will it always stay paper, or will it break up into the pieces, like the building blocks that make up paper? Okay. So now we have these 4 students. It will still be paper no matter how many times you cut it up or how small it gets. When you cut paper in half, it is still paper. So no matter how small you cut it, it will always be paper. That is going to be the continuous model. Student B says paper is made from wood. As you keep cutting paper smaller and smaller, you'll eventually get to the stuff like wood that paper is made of, so you'll no longer have paper. That's the particle model of matter. That means that it breaks up into something that's not paper anymore, that you put together to make paper. Student C says the paper will eventually get so small that it will turn into dust instead of paper. So that one is going to be the particle model of matter, because that's something different than paper. But you'll notice in my Google form that I made that I had a question that is paper dust, and that one is saying that it's still paper, it's just like the tiny particles of paper. So on the Google form, that one is going to be continuous, but here this is particle. Student D says if you had fancy enough equipment, you can continue dividing the paper into smaller pieces, but eventually it would not be paper anymore. You would have tiny pieces that are different than paper. That's going to be the particle matter. So we have, does it stay paper when it's small, or does it not? If it stays paper, it's continuous. If it breaks up into different pieces, then it's the particle matter. Okay? So then question 4. So student A agrees with the continuous model of matter. Student B agrees with the particle model of matter. Student C agrees with the particle model of matter, and student D also agrees with the particle model of matter. I think each one is pretty clear on which one they are. So now you put what you think about which is which. Okay, so that's activity 1. I'm going to go ahead and keep going into activity 2, and I'll probably make a separate video for activity 3. Okay, so then we have this idea of, does 5 plus 5 always equal 10? And to do that, we were looking at ethanol versus water. So in this first one, you drew pictures of what you think water, ethanol, and the mixture would look like if you could zoom in and see their structure. So that's like an open-ended drawing that represents kind of like what you wrote in the warm-up question that day, which is, how would you show the differences between ethanol and water when they look so similar, but they have such different properties? So in this drawing, if you drew little bits of things, that's going to be the particle model of matter. If you drew more of like a flowy, kind of just more like liquidy looking kind of picture, that would be continuous. So then we mixed those liquids. When we mixed water plus water, it was just what we expected, 20 milliliters from 210 milliliters. When we mixed ethanol plus ethanol, it was 20 milliliters. It was just what we expected, 20 milliliters, 10 milliliters plus 10 milliliters. But when we combined water plus ethanol, it ended up being lower. Most of the time 18 milliliters, although one class got 19 milliliters, but I think maybe it's just we didn't mix it quite enough. But definitely a lower volume than we expected. So the patterns that we see, this is going to look a lot like our tape patterns here. When we combined 2 like liquids, they added up to what we expected. When we combined 2 unlike liquids, they added up to less than we expected. So here we have a model that explains the volume you observed after mixing the water and ethanol. So I did this kind of like an equation. I used lots of copy and paste in this one. I drew my box here, and then I copied it, and then I copied it again, and then I just moved this thing up and wrote 2 times. So this is like x, 1x plus 1x equals 2x, right? 1x plus 1x equals 2x. 1x plus 1x with a mixture equals 1.8x. So that's the kind of thing we're looking at here. And my explanation for that is essentially, it's actually almost exactly this thing. When I combined 2 like liquids, they added up the way I expected them to. When I combined 2 unlike liquids, they added up to less than I would expect them to. Okay, so then we looked at a computer simulation of why this would happen. And you got to choose between the particle model, which looks like this, and the continuous model. So the particle model ends up looking like what we did more, because we have water coming in there, we have ethanol coming in there, and let me shake them all up, and you can see that those water molecules, because they're smaller, they fit in the spaces between the ethanol, and that makes it kind of more of an efficient use of space, which means that it takes up a little bit less space than it did. So that the particle model fits better. The continuous model adds up to 2x, so that's not what we saw in our experiment, right? And it turns out that the particle model is the true, that's what really happens. You guys have heard about atoms, you guys have heard about how atoms are put together to make different substances, and that's exactly what's going on here. We can see that, that there are different particles of different things going on here. So when we combined the substances and shook them up, they added up to less than we would expect, and that's why we chose the particle model here. So we chose the particle model because when we combined the substances and shook them up, they added up to less than we would expect. So use your observations of the simulation to explain why mixing ethanol and water results in a measured combined volume that is less than the sum of the original volumes. When we mix ethanol and water, the water molecules are smaller and fit in between the larger ethanol molecules. So just to show you what the difference between ethanol and water molecules look like, this is a water molecule. It's super simple, just an oxygen with 2 hydrogens. And if you can imagine that water molecule being the same size as these atoms here, this is an oxygen, hydrogen, this is ethanol. I think it looks like a dog. But you can see that this molecule is a lot bigger than water, and so that water molecule would fit in between the spaces there. Okay. So revisit the model of mixing water and ethanol that you drew after the hands-on experiment. So that was the one that was, let me flip back to that page. That was this model right here. Okay, so we're looking back at that one, and we're wondering, do the components in that initial model explain your observations of water and ethanol? What revisions would you make to your model? Okay, so in that model that I drew right there, I didn't show the particles. I just showed like the amounts there. So if I could revise my model, I would show that the substances are made of particles of different sizes that can fit together in a more, I like to say efficient, I guess, because it takes up less space, in a more efficient way than just the particles on their own. Small particles fit within large particles. Or not really within, but like between. Okay? So that's the end of this one, I believe. Yep. Okay, so I'm going to call this video done, and I'll be back for activity 3.